So, welcome back. We have the next block of interesting talks ahead of us. And the first one will be entitled Using Google Lighthouse to Analyze Shiny Applications. It will be presented by Oshin McCosker. So, Oshin is a data scientist and training at Jumping Rivers, and his background is in mathematics. So, we are pleased to have you here with us. So, when you're ready, you can start, Oshin.
Hiya, thank you for the introduction. So, welcome to my talk using Google Lighthouse to analyze Shiny applications. My name is Oshin McCosker. I'm a data scientist and trainer at Jumping Rivers. I work mainly with Shiny in development and best practices. So, who are Jumping Rivers? If you haven't heard of us before, we are a data science consultancy who do data engineering, Shiny consultancy, and training in R, Python, Stan from beginner to expert levels. And the main topic of this talk is Google Lighthouse. So, as you might have guessed, it's a tool made by Google. It's open source and it's for analyzing startup times and other metrics from web pages. But we can also use it on Shiny apps. So a quick spoiler alert before I get into it. Google Lighthouse isn't going to speed up any slow database calls or badly written Shiny apps. But what it can be useful for is benchmarking and testing your Shiny app load times, making small gains, and just assessing your app in general. So a Lighthouse report is typically going to look something like what I've got on my screen. I hope you can see that okay. But we've got the overall performance score here, and it's out of 100. You can see I've tested the Jumping Rivers website, and we have a score of 100 here. And then underneath is all the separate metrics that are being tested here. And I'll go into a little bit more detail on those in a second. But you can see our website's done pretty well. So how do we use Google Lighthouse? So there's two ways. The first way is through the terminal, and to do this, you'll need to have npm installed. And to install Google Lighthouse, you do npm install -g Lighthouse. And then to actually run a report, you'll need to use this snippet of code, Lighthouse, and then you specify the output format, mainly JSON or CSV, and then the output path where you'll want the report file to go, and then the URL of the Shiny app or web page you'd like to test. So this can be an app hosted on Posit, shinyapps.io, or something like that. Or if you're testing an internal app, the internal URL, or a local app, the local host URL provided to you upon running the app. We can also add the preset as desktop, as by default, the Google Lighthouse measures the mobile kind of web page or app, so we can add desktop as this is more applicable to most Shiny apps. We can also use DevTools in the Chrome to measure Shiny apps, and to open DevTools, you can do Control-Shift-I, F12, or just inspect on a web page, and I'll show you that now. So to go to DevTools, once you've got the DevTools menu open, is you go to the two arrows at the top here, and I've already got Lighthouse open, but if you don't have it open, it'll be one of the options on here. And this is how you test a web page just through DevTools, just by clicking this Analyze Page Load button here. Now, I'm not going to do that now, but you can see all the preferences you can set when running a test through DevTools. So I'll go ahead and close that. So now I've got a little bit of information on the metrics being measured by Google Lighthouse. Now, I'm not going to go into too much depth here. If you'd like more information, the documentation for Google Lighthouse is pretty good. So you can go and have a look there. So the first metric is first contentful paint. And this is the first point at which the user can see some content or something on the screen. Then we've got the speed index. So this is how quickly the visual contents of the page is loaded. We've got the largest contentful paint, which is the point at which the main piece of content on the web page or Shiny app is loaded. We've got the total blocking time, which is the time between first contentful paint and the point at which the app becomes interactive. So the last iteration of Lighthouse had a metric called time to interactive, and this is used to calculate the total blocking time. And we've also got cumulative layout shift, which measures the visual stability of the page whilst loading. And I've got a little demo for that here. So this is some documentation for Lighthouse with a nice little video describing how cumulative layout shift works. So if I click on this video here, you'll see when it goes to the start, but they've incorrectly tried to order 56 items. So they click no go back, but due to the cumulative layout shift of the website, the submit order button goes to where the cancel order button was, and they end up ordering the items they didn't want to. So this is a great video demonstrating cumulative layout shift. And this website also has lots of documentation on all the metrics measured by Google Lighthouse. So if I go back, I'd also like to demo a nice little widget Google Lighthouse provides for looking at how each metric impacts your overall Lighthouse score with the weighting. So this is a lovely HTML widget where we can see how the increasing of each metric is going to impact our overall Lighthouse score. You can also change this to be mobile, and you can also change different versions of Lighthouse as well. So you can see the time to interactive from the last iteration, which has now just been bundled into the total blocking time. So if I go back to my slides, there we go, on full screen. So now we've done a little bit of background on Google Lighthouse. I wanted to mass test some Shiny apps, some Shiny apps using Google Lighthouse. And I used the 2021 Epsilon Shiny App Contest entries because that was a great place to find lots of Shiny apps. So this involved me going on the website and manually determining which links still work to the apps that are hosted on shinyapps.io. And this was quite mundane. And then saving the link if they worked, add it to a list, and then I mapped over the list and ran a Google Lighthouse report for each app. I tested about 130 apps in total, and I only really had time to run one report on each app. If I try to do more, I think it would have taken too long. So what did I find? So now I've got a few little plots from the data that I obtained. So this is just the overall score for the apps, a histogram, and we can see we've got most of the apps in and around the 60 to 90 mark, with the mean being 73.2. We have quite a lot of very good scoring apps and then a few on the lower end of the spectrum. This is another histogram showing the distribution of all the metrics that are measured. And I'll just leave this up for a second. So from the Lighthouse documentation advice, 90 to 100 is an app with good performance, 50 to 89 is an app that needs some improvement, and then 0 to 49 is an app with poor performance. So going off these guidelines of the apps that I measured, most of them had the need for some improvement, and then more of them had good improvement than had actually poor performance, with an average score of 73, like I said. So I'd say if your app is above 73, you're doing pretty well. A few issues to be aware of that I noticed are the contentful paint metrics will sometimes not fully track widgets. So they might, for example, think that a plot has fully loaded when in fact it's only the frame that it lives in that's loaded. So this can lead to some misleading Lighthouse scores, although I think that the total blocking time, which contains the time to interactive, will kind of even these out a little bit. But this is just something to keep in mind, as the final Lighthouse score would provide you with a screenshot of the app when it thinks it's fully loaded. So if that's what your app looked like when it is fully loaded, then you're okay, but it might just be loading the frames and timing that. So this slide is pretty hard to read, but it says, the next thing I'm going to talk about is I wanted to use Google Lighthouse to analyze what impact components or widgets in a Shiny app have on the Lighthouse scores. So this is a little segue to the Jump Rivers annual Shiny in Production conference, where we do all things Shiny. We have some great talks and workshops, and it's a great place to network. And it's taking place in Newcastle in the north of England. And I'm talking about this because this section of the talk was inspired by Colin Fay's talk, Destroy All Widgets, at the Shiny in Production 22 conference, where he talked about the impact of HTML widgets on Shiny apps. So what I did was grab the first Shiny example, just a nice simple app with a slider input and then a histogram with the number of bins. And this is just the run example 01 hello Shiny example. And I wanted to iteratively add more complexity to the app whilst running Lighthouse reports and see what the reports look like. So I'm not going to show all the apps, but the third app, I've added a plotly instead of the histogram, the base histogram, and I've added a data tape and just a base data table here. And then the last app, I've got two plotlies, one interactive DT data table, and a date input. And the overall changes in the apps were, in the first app, it's just a slider input and a base plot. The second app, I changed the base plot to a plotly, interactive HTML widget. Then I added a simple data table. Then I changed that to a DT table, which is another interactive HTML widget. Then I added a date input widget. And then in the last app, I added a plotly app in the side, a plotly plot in the sidebar. So now I've got a few more plots with my findings. So you can see as the apps get more complex, you can see that, as you might expect, the Lighthouse scores take longer. So the speed index is taking longer and the time interactive is taking longer. And there's a huge jump between adding the first plotly and then the next widget, which is the data table, and then the increases aren't as bad. So I'll leave that up for a second, where we've got the apps going from app 1 to app 6. The next one, I just did the app on the y-axis versus speed index, and we can see that, again, as we might expect, as the apps become more complex, they take longer to load, but also the variability of the load times and speed index increases. This next plot, I've got score versus first contentful paint. And in this plot, you can see that the score for the Shiny apps is decreasing as the apps get more complex, which is to be expected. And we also have the time for the first contentful paint to load increasing. But from this plot, I noticed a few outliers where the overall score is below 90 for the same app. And I thought that was strange, because why would the same app have a different overall score on different runs? And in fact, the most complex app, app 6, had no below 90 scores. So to look into this a little bit more, I saw that 9 of the I had 6 apps. I ran each app 10 times, and 9 had below 90 overall scores. So almost a sixth of them, and they were all coming in apps 4 and 5, despite app 6 being the most complex. So I made a little radar plot comparing them, and you can see that the orange is the below 90, where they're scoring more on each metric apart from the score. And then I thought this could only be caused by the Wi-Fi, so I looked at the time I ran the reports. So I ran them from 3:10 to about 3:25, and you can see this clump here where all of the bad, well, not bad, but the sub 90 Lighthouse scores are coming in. So I think it is due to a drop in Wi-Fi at this time. So here's the final words. It's Lighthouse is a great tool to assess your apps, but you have to take it with a grain of salt, as shown by the Wi-Fi issue that I had here. And it's important to run your app multiple times with Lighthouse just to get a fair result. And it's also shown from my results that, as you would expect, HTML widgets will slow down your apps, but they're what makes Shiny apps useful. There's no point having a Shiny app where the user can't really interact with the data in a nice way. But you have to bear in mind you are sacrificing a little bit of performance when adding the widgets. And it's also important to keep the user first when creating the app. So don't put a widget in for the sake of it if it's not going to help the user out or if it's not going to benefit the user. And that brings me to the end of my talk. So thank you for listening. My email address, if you'd like to contact me, is oshin@jumpinrivers.com, and my GitLab and GitHub username is @oshin1.
So thank you, Ocean. That has been very interesting content. And we have some questions. The first one from Josh Conley would be, how noticeable is the speed difference between a 100 score app and a slightly below average score app?
So the speed difference is going to depend on what's in the app, but it could be anywhere from about milliseconds to a few seconds. It's not a huge difference, but it would be noticeable for the user, I think.
Okay. And yeah, maybe another question is from Christy Conrys. I haven't heard of Lighthouse until today, but what is the benefit of using it over Google Analytics?
I'm I'm not sure, to be honest. I think Lighthouse, as I said, is a good tool for benchmarking your Shiny apps and also just getting a gauge of what the load times look like.
Okay. So yeah, thank you very much again.